What could go wrong if when object A is in thermal equilibrium with object B, and B is in thermal equilibrium with object C, A is not necessarily in equilibrium with object C? In other words, kind of the example we were looking at earlier, right? If I say, okay, I take this object, put it in contact with this one, no heat flows. Then I say, okay, take that object and put it in contact with the third one here, C, and no heat flows. That would establish that the temperature of A and B is the same, and the temperature of B and C is the same. But now I say, okay, but let's say I take C and put it in contact with A, and now I see that there's a heat flow, which, based on my, so far I think, kind of intuitively stated definition of temperature, would suggest that A and C have different temperatures. And that would be weird because they're both supposed to have the same temperature as B, right? So hopefully we can all appreciate how that would be weird. Let's see what the answer to this question says. It takes maybe a somewhat more even practical approach to this. Suppose A and B are both thermometers, right? If A is in equilibrium with B, that implies that both read the same temperature. Then B in equilibrium with C would imply that C is at that temperature. In other words, B is giving us a correct reading for the temperature of C. But since A and C are not in equilibrium, right, because we said that when we connect A and C, there would be heat flowing, that would say that thermometer A would have to read a different temperature. But we just said thermometer A is definitely reading the same temperature as B because they are in equilibrium with each other. So if nature allowed something like that to happen, you couldn't really have thermometers be able to really measure something that we're calling temperature. In other words, basically temperature would be a bad idea.